Hi, I'm JBovee, and I'm in ECE 311 and 331. Today I'm going to talk a little bit about an RC circuit and a rectifier circuit. First, I'm going to talk a little bit about time invariance and linearity with the rectifier circuit, and then I'm going to talk about it with the RC circuit. So now we're going to take a look at the rectifier circuit. Okay, here's the whole circuit we're going to look at today. And here's the rectifier that we're going to focus on first. Now I'm going to look at the linearity of the rectifier. This is a full wave rectifier, and there are a couple ways we can know it's not a linear system. First is diodes are not linear circuit elements, but I'll get into that a little later. And second is linear systems can only shift and scale the input, and the rectifier does not do that. The input's going to be a sine wave, and the output will only be positive. So we know it was not only shifted and scaled by the rectifier. Now I'm going to talk a little bit about the RC circuit. Now we're going to take a look at this RC circuit portion. Now I'm going to talk about the purpose of the RC circuit. So this RC circuit is linear, and the purpose is to smooth the signal coming out from the rectifier circuit to give a DC signal, or close to it. There will be a bit of a ripple effect. Increasing the capacitance, though, can minimize the ripple. We do know this is a linear system, though, so by itself, it's not possible for it to change an AC signal to a DC signal. That's why the rectifier is needed. By scaling or shifting an AC signal, there's no possible way to make it DC. An AC source has a DC component of 0, and so there's no way to shift or scale a 0 to anything more than 0. That's why the rectifier circuit, which is nonlinear, is needed. Now let's take a look at the two circuits together. So if we look at Vin and assume it is input cosine, when it's positive, it will go up and around and then reach the rectifier circuit in between D4 and D1, and it'll go to D1, and then it'll travel through the RC circuit and come back around and go through D2 and go back in to the negative side. Now when Vn is negative, it's going to go down to the node between D3 and D2, and it's going to go up D3 and then through the RC circuit and then back down and then through D4 and return. The rectifier, this is how the rectifier creates always positive waves. The RC circuit always sees Vn as positive. Okay, now I'm going to talk a little bit more about diodes. The full wave rectifier works because diodes only let current travel through them one way. And this is because of the depletion region. And here we'll take a look at it. Okay, what we're looking at here is a PN junction with the depletion region in the middle, which is creating an electric field. This depletion region can grow or shrink, and that depends on the potential in which way it's going. And when the depletion region grows, it creates a stronger electric field, which then makes it almost impossible for current to go through it. This is why current can only flow one way through it, which is a key part of the full wave rectifier we looked at earlier. Thanks for watching my presentation, and have a good day.